Good morning, this is Miss Young here. In the first video we looked at the method of how to convert from a decimal number through to a hexadecimal number. It was limited to a 2-digit hex number. In the second video we implemented that algorithm in a number of different ways, and in this video I'm going to take that exam reference language for OCR and I'm going to convert that to Cambridge IGCSE pseudocode. In the exam reference language we looked at 3 different ways of doing it. Unfortunately, one of those ways, the third way, is not really very practical in Cambridge IGCSE, so we'll just look at the first and the second. So the first thing that I'm going to do is just simply copy the code from the exam reference language and code into here. This is a useful online editor. It doesn't really work particularly well, I'm afraid. It's quite old, but it does do some nice highlighting and it makes it easier for me to show you on the screen. Let's look at the simpler things. Obviously, it's unlikely that you would get penalised for using lowercase, but technically we would be using uppercase for procedure. Now, in Cambridge pseudocode, we don't have the ability to enter an input and a prompt at the same time, and so we're going to first of all need to simply output. So we're going to take the prompt and we're going to output that. Now again, we do need to declare, or unless it tells us otherwise, we need to declare our variables, and we can see we have D number. Now technically they like Pascal case, which is every word capitalized. So, and that, of course, that's going to be an integer, and I'm just going to change these before I move on. So again, we do things very differently. It's input D number, and so again what we're going to do inside of the while loop is just going to copy that same code. Now again, we still use whiles, just capitalized, and we also, well, it's a little bit debatable. Technically, in the IGCSE pseudocode, we have a do, although that is not required in the A levels. So it would be rather strict if they dock you a mark for not using do, but I'm going to go and do it as per the specification. So we then need to do digit, and I'm just going to, I should have updated these numbers as well, just to keep everything constant. And before I worry about this, of course, these are going to be integers as well, so I'm going to add these to the declaration. Now I don't normally add these until the end so that we can worry about the code first and then add the declarations later, because when we're writing the code we don't have a lot of time, we don't have to think enough time to think about what we're going to do. We kind of have a little time to plan, and then we need to move on rather quickly. So again, a little bit interesting, according to the A-level pseudocode, this is how you would do div and mod, but technically if I want to do it at GCSE, it would look like this. Again, it would be a very strict examiner who marks you down for using the other method, and I think the other method makes more sense, but technically according to the IGCSE pseudocode guide, this is the way to do it. Now again, we've got H digit, but the reason I'm going to not make a change on that will become apparent later. Now again, Cambridge pseudocode, unlike ERL, unlike Python, does not have an ability to convert from an integer to a string or vice versa. What they do say is that if you need such a a function, then it will be provided in the question. So technically speaking, what we do know from the A-level specification is we have something called num to str, and so I'm going to use num to str and assume that that would be given to you as part of the question, and I'm just going to update those. And so as we can see, not a great deal of things to be changed, and again it would be a rather strict examiner unless they specifically told you num to str to not use str, but that's how it would be done. Obviously this is capitalized, so, and in pseudocode or Cambridge pseudocode, it's not switch, it is case of digit 1, and then we don't need the individual case key words here, and of course this would be end case. And of course the reason I told you I'm not changing that is because there's a lot of things to change here. If you're writing it from scratch, then that would be fine. So there's not a great deal of difference here. It's case of instead of switch, and we have a capital end if here. So what I'm going to do is I'm just going to copy, no, let's just do it again so that we can check and show capital F, capital then, and I had this as capital D, and then instead of switch we have case of, and I don't need this, I've just spotted that I don't need that here. Then we can get rid of the keyword case, and we have end case, and of course that should be indented. And then we have the end if, and we use, as we've seen before, we use output and spell properly, and no bracket required, and instead of the plus symbol we use an ampersand. And so what have we changed? Well, of course we also have h digit, which is a string, so we ought to declare h digit 1 and h digit 2, and they are both string. So we did our declarations, we are outputting and inputting. This didn't change except for capitalization, potentially a do. This, we could have written it the other way around. There wasn't really any change in terms of that. No change, save for using num to str. Again, instead of switch, we used case of. If remains the same except for capitalization, and we use output and ampersand. But between that, again, it's not really about understanding a specific coding language. It's more about understanding how to do the problem itself. So now, as I said, this decimal to hex just is not viable. So I'm going to go and do this decimal to hex here, and we'll copy and paste that down here. So again, there's no point in reinventing the wheel. I'm going to take all of this code and I'm going to paste it down to here, and in in Cambridge it's there, and for some reason this doesn't like this, so I'm just going to call it that, and I'll come back to what's happening here in a minute. But for the moment, and I will just, because it's convention, put all of these at the top. So if you remember, this should just be a capital, but no real change here. No real change here. So now what is the difference here? Well, of course, we can say it's just capitalizations, pure capitalization. And in fact, again, there is no standard way in Cambridge IGCSE of converting between ASCII and its ordinal value, or the ordinal value and the character. However, again, in the insert for A-level, it does in fact use ASC and CHR, so we're going to assume that they have been given to us as part of the exam question. If not, we would have to do it this way. It's more likely that they're going to want you to do it this way, but either way, they're going to have to give you a non-standard function that is not included in the pseudocode guide for the specification. And so let's just capitalize those. And again, no real change here. Beyond capitalization. And we already went through how that worked, so I don't really need to take you through it again, but just for those of you that are watching it on only for this video, I'll take you through it in a moment. We have output, and if you remember, we use an ampersand. So what is happening here? Well, ASCII A, this function ASCII will take the ordinal or the numeric value of A in the ASCII character set. I just happen to know that's 65, so that will return 65, take away 10. And the reason for that is because we're only interested in numbers from 10 to 15. So if we have the number 10, we take away 10, which would give us 0, and then we would add on 65, which would give us 65, and then we convert that 65 to an A. So if we had the number 1, then we would take, the number 11, we would take off 10, which would give us 1, add on 65, which would give us 66, and then the CHR would convert that 66 to the uppercase B. And so that is how that would work, and it saves us a little bit of code. It doesn't look that much less, but you can see here we have from lines 7 through to 44, and then from here we have from 51 through to 77, so there are a few less lines of code. Of course, the other method, the third method, which we can't simply do here, is even fewer lines of code. So it depends on how you asked in the exam, but that is how we convert the exam reference language, or how we implement the decimal to hexadecimal algorithm. Of course, again, we are cheating because the question limits us to 255, which means that we don't need to go and calculate the highest placeholder and start going through those and dividing by those. We can simply cheat and do div 16 and mod 16 in order to do this problem. So that is the implementation of the algorithm in Cambridge IGCSE pseudocode, and in the next one we will be looking at how to implement it in Python, which either you can do that as part of most specifications, but is also the pseudocode base for Edexcel. So I've been Miss Young, I hope that's been helpful. Goodbye.